Jai Hind, dear students. Welcome to the lecture series of manufacturing processes, that is BME 403, and here the targeted students will be the second year 4th semester students. So in today's lecture, I am going to discuss about the fundamentals of manufacturing processes and its classifications. So I am Dr. Suman Gothwal, working as Associate Professor in the Department of Mechanical Engineering at Akgec, Garg. So first, we are going to discuss about the manufacturing processes, and today's the outline will be the introduction to manufacturing processes. First of all, we will see what is the manufacturing process, how we will define a manufacturing process. Then we are going to discuss about the basics of manufacturing processes, or we can say the material processing techniques. So we have classified into different types of manufacturing processes, like you can see here the casting processes, forming process, or we can say the metal working processes, and then we will discuss about the machining processes, joining and assembly processes, and in last we are going to discuss about the rapid prototyping processes. So first we will discuss about the manufacturing process. So what is manufacturing? How we will define a manufacturing? So when we convert the raw material into the final product, that is the manufacturing, okay? And we can do this with the help of different processes. What is the meaning of processes? So it is the sequence of operation with the help of which we are converting the raw material into the final product. So here you can see that manufacturing processes is basically converting the raw material into the final product with the help of a single operation or a sequence of operation. So for converting the raw material into a final product, it may require only single operation or it may require n number of operation. That will depend on what we want to manufacture. Now the phases of a manufacturing processes. So we have divided this manufacturing process into different phases. So we can see we require the designs. First of all, we should have the design what we want to manufacture, what will be the shape of our final product. Then we select the material. So material will be selected on the basis of what type of function or what are the applications of that particular product, okay, or particular design. Then we will select the process. Means depending on the design or depending on the shape of the final product and what type of operations are required to get that final shape, we will select the different number of processes. Okay, so these are the phases of a manufacturing processes. Now we can come to that when we going through a manufacturing process, there will be some changes. What will be the changes? It will change the physical properties of material, because it may go through the casting process, it may go through the machining process or the joining process. So it will come in contact with different factors which will change the physical property of our raw material or the sub manufactured part. So it will change the physical property of the material. Next, it will change the shape and size of the workpiece, okay, because we want a particular shape. So it will change the shape and size of the workpiece, and after this we will get the desired dimensional accuracy and the surface finish. Now we come to the basic material processing techniques, or we can say the classification of manufacturing processes. So we have classified these manufacturing processes into a number of processes. You can see here that we have divided it into different processes. So here we can see the various steps or series of operations which are used in manufacturing or converting the raw material into the finished product are known as material processing, okay. And the different processes are casting process, then we have forming and metal working process, then we have the machining processes, joining and assembly processes, rapid prototyping, and other type of processes. So, we will discuss all these processes one by one in the coming slides. Now, we come to the casting processes. So, casting processes is the primary type of manufacturing process. Means here we do not talk about the accuracy or the tolerances or the surface finish. This is the primary manufacturing process. It means that it will provide us the basic shape and size of the desired shape. Okay. So, what we do in the casting? So, here you can see a diagram. This is known as basically pattern. Okay, this is known as the pattern. So, first step in the casting process is we should know that what we want to design, what we want to produce. We should have the design of our final product. Okay, after that, what we do, we design the pattern, we produce the pattern. So, pattern is basically the replica of the final product. Okay, and with the help of this pattern, we can see here that the pattern is divided into two parts. Okay, so what we will do, with the help of these two parts, we will create the cavities. Okay, and these cavities are known as mold cavities because these are produced in the molds. And here you can see these are two boxes which are the cope and rag in which these cavities are produced. So, with the help of the pattern, first we will create the mold cavities. Okay. So, these two boxes can be of wood. You can see here these are made up of wood, or these can be of metal. Okay. That will depend on our requirement. Now, you can see here that these are placed one above the other and these are properly aligned with the help of dowel pins. Okay. After that, we will fill these boxes with the help of sand or the metal. It will depend on what type of casting we are working with. We are performing the sand casting or the metal casting or permanent casting. Okay. And then we will create the mold cavities. After the cavities are created, here in this diagram, you can see here that the molten metal, okay, that the molten metal is poured into these mold cavity with the help of a passage, and then these cavities are allowed, these molten metal which are filled with this molten metal are allowed to solidify, and after that these solidified parts are ejected from these molds. Okay, and the parts which we will get is our final product. Then after this, we can do the post processing operations. Either it is machining or the other operations which are required for getting the accurate shape. So, these are the steps basically which are involved in the casting process. So, here you can see the first point is the mold cavity is created with the help of the pattern. After that, the material is heated to a specific temperature, and then this molten metal is poured into this mold cavity. Then it is allowed to solidify and then casting is removed. So, this is the primary manufacturing process. Then we come to the forming process or the metal working process. So, in this process, basically what we do, we are producing the required shape and size with the help of external forces. Okay. So, you can see here the material forming includes a large group of manufacturing processes in which the required shape and size is obtained by plastic deformation. Means we will plastically deform the material. We will change its shape and size with the help of external force. Okay. So, for applying the external force or changing the shape and size of our raw material, what we will do, we will heat the material to a temperature which is below the solidus temperature. Solidus temperature is basically the highest temperature at which the material is in its proper solid state. Okay. So, we will heat the material below the solidus temperature, and then the external force will be applied such that the material flows and takes the desired shape. Now, how will it take the desired shape? So, we can use the different dyes, we can use the dye, and we keep the material in this particular dye, then we will apply the force with the help of dye and it will take the shape of the dye. So, in this way we can use the different tools and the equipments to give the particular shape what we want to produce. Here you can see that the material is heated below the solidus temperature, and after that we are applying the external force with the help of hammer. Okay. So, here we are providing it a particular shape which is desired. The volume of the metal of the product remains constant before and after the forming process. So, here no wastage will be done. Okay. The volume will remain constant before the forming process and after the forming process, because here we are only providing the shape and size with the help of external forces. An example of these forming processes are rolling process, in which the large size rollers are used to produce the sheets. Okay. And we have the forging process, in which we can use the external roll like the hammer we can use, and then we have the extrusion process where the material is a heated billet or heated material is extruded with the help of an orifice to produce the rod type shapes. And then we have the wire drawing operations, in which we use the stretching force, tensile force to form the wire. And then we have the tube drawing force, in which the heated material is passed through a tube to produce the roll like shapes. So, these are the different types of forming processes which we can use. Now, we come to the machining processes. So, machining is considered as the secondary manufacturing processes, because here the material is produced with a good surface finish and the dimensional accuracy. Okay. And this is the expensive process. This is the most expensive process, and we can say almost all the materials undergo these machining operations in its life duration at some points when we require the dimensional accuracy, when we talk about the tolerances. Okay. So, here basically how we produce the required shape and size by removing the unwanted material in the form of chips. Okay. Chips are basically the undesired materials, and this is removed from the blank material or the raw material by a cutting tool, which is harder than the raw material. Okay, to obtain the desired shape. So, here in these two diagrams you can see here we are using a drill bit in the first diagram, in which we are drilling a hole, and here you can see here the curls, which are the chips, which are the undesired materials, and these are removed in the form of chips. In the second diagram we can see here the turning operation is done. In the turning operation basically we reduce the diameter of the workpiece, and here the unwanted materials is coming out in the form of curls, and these are known as the chips. So, we in machining operations we are providing the required shape and size with the help of removing the unwanted material from the raw material. So, it will produce the dimensional accuracy and will provide the good surface finish, and the example is for example turning, in which we reduce the diameter of the raw material, drilling when we drill the hole, and shaping where we use the different shapes or shaping tools to provide to produce a given profile. And then we can use the milling operation, in which the milling cutter is used to produce the required shape, and then we can use the grinding or broaching also. In grinding operation, basically we use the grinding wheel, and in broaching we use the broaching tools. Okay, so these are the different machining processes. Next we come to the joining process. So in basically joining process, different materials which can be the metals or the plastics we use to join these parts. Okay, so it basically involves the joining of similar and dissimilar. It can be the similar materials or the dissimilar materials. So here we basically join these similar or dissimilar materials or plastic either permanently or temporary basis. Okay, if we talk about the temporary joint, then with the help of the screw, nuts, bolts, we join the two parts. Okay, but we can remove or we can separate these parts without breaking the joint. Okay, and but in case of the permanent joining, what we do, for example, we are joining the parts with the help of welding operation. So in that case, if we want to separate these parts, we have to break the joint. Okay, so it will depend on our requirement that whether we want to go for a temporary type of joint or the permanent type of joint. Okay, now the joining can be accomplished with the application of heat. Okay, with the help of with the application of heat. For example, in case of welding, we use the heat. Okay, or with or without the application of pressure to a joining material. So depending on the type of welding process that we are using, it will basically tell us that we will apply only the heat or the heat and the pressure. Okay, this will depend on the which type of welding process we are using for joining these materials. So some of the some of the processes under this category are, for example, gas welding. We can use the arc welding, resistance welding, thermit welding, cold welding, brazing, and soldering. So these are some of the welding processes which we can use for joining the material. The brazing and soldering basically are used for the small joints. For example, you can see here we can use it in the case of the motherboards. So we for the capacitor or the small joints, we can use the soldering or brazing. And for these gas welding or the arc welding are joined for the large joints. Okay. Now we come to the assembly process. Means assembly process is basically the assembling of different components to get the final product. Okay, so here we can see here the part or materials are assembled in a sequence to get the final product. In this diagram, you can see here that the different components of a car are assembled together with the help of the robotic arms to get the final product. Okay, so this is the example of assembly. And here the type of assembly method will depend on the material being assembled and how durable the final products needs to be, and the nature of assembly, either permanent or temporary. So these are basically the factors which will define the type of assembly required. Means what is the application of that product, what are the how many number of components are assembled, and type of assembly we require, the materials that we are using for the assembly. So all these will define the type of assembly required. Now we come to the rapid prototyping. So rapid prototyping, rapid is fast. Prototype is prototype is the replica of the final product. So rapid prototyping, in this basically there are number of techniques are involved in this. So different rapid prototyping techniques are available which are used to fabricate a physical object. We can manufacture a physical object, and what we need for this is the CAD model. Okay, so three-dimensional computer aided design or CAD data. So the first requirement of the rapid prototyping technique is we should have the CAD data or CAD model of the final product. Means we should have the design what we want to produce. Okay, so in rapid prototyping techniques are not only used for making the prototypes or the but these are used for making the production parts and tools, etc. So integrate products or complex products which cannot be produced with the help of the machining, other manufacturing processes. We can produce it with the help of rapid prototyping techniques. Okay, so different types of rapid prototyping techniques are available. For example, we can use the stereolithography, we can use the selective laser sintering, SLS, or we can use the direct metal laser sintering, that is DMLS, fused deposition molding, FDM, binder jetting, or the 3D printing. So in this diagram, you can see the sequence of converting the CAD model into the 3D object or prototype. Okay, so in this diagram, we can see here, first step is we should have the 3D CAD model with us. So this is the 3D CAD model which is available with us, and then this is this CAD data which is available with us is converted into the printable file, or it is converted into the format which the machine can easily understand, like the STL format. It is converted, then with the help of the slicing software, what we do, it is sliced, it is divided into different slides of particular thickness. You can see here the layer slices and the tool path. Okay, and after that, with the help of additive manufacturing process, or we can say the rapid prototyping techniques or 3D printing techniques, what we do, we manufacture the final product with the help of depositing the layer by layer. Okay, so here we can see the layer by layer, it is material is deposited, and after that what we get the final 3D object which is similar to the 3D CAD model. So we can use these different types of manufacturing processes. So in today's lecture, basically we defined the manufacturing process, we classified the manufacturing processes, and we discussed it with the help of examples. So thank you so much. This is all for this lecture.